Assalamualaikum warahmatullahi wabarakatuh. Hello, welcome back to Ponyo's Physics, and today we will learn about projectile motion. Let's get started. So, first things first, what is projectile motion? Well, it is when an object is projected in. Okay, you know what? Let's see the animation. Okay, it is when an object is projected in the air and it creates this parabolic path. And yeah, that is called projectile motion. So, are you still confused? Well, so am I. So, you know what? Let's just draw it down on the big whiteboard. Let's go. So, there are four things that you need to know about projectile motion. The first one is you need to be able to determine the x and y components. The second one is you need to be familiar with resolving vector. The third one is obviously formulas, accelerated motion formulas, and the last one is KE and GPE. Okay, so first of all, let's start with determining the x and y components. As you can see on the diagram, I am making the parabolic path and two different colors to make it much simpler. Next is that I will draw three different balls in three different positions. The first position indicates where the ball has just been projected. The second one is at the top, means that the ball has reached the maximum height, and the third ball is when the ball almost reached the ground. So next is to draw the x and y table components. There are 5 components, which are: S means displacement, U means initial velocity, V means final velocity, A means acceleration, and lastly T means the time. Okay, now let's fill the table. First of all, S and also U, they will be given or will be looked for in the question. Now, second is the velocity. Let's talk about velocity in the x component first. And it is said that final velocity equals to the initial velocity. And why is this happening? It is because when we look back to the diagram, we can see that there is no change in the velocity in the x components. So, it will be constant. The initial and final will be the same. Now, as there is no change in the velocity in x component, that means the acceleration in x component will also be 0. And lastly, for the t, the time will be equals to time in the y component, as time is scalar, so it doesn't have direction. Moving on to the y components, we can see that there will always be gravity, right? And gravity equals to 9.81. And as we indicates that upwards means plus or positive and downwards means negative, so we can say that the acceleration in y direction is negative 9.81 meter as minus 2. Now, moving on to the final velocity in y components, there will be another way to find this component, which is using the resolving factor. Let's do this! So before I want to dive into resolving factors, I would like to say that the velocity in y components varies. As we can see in the animation, speaking in terms of velocity in y direction, the first position goes upwards, second position has no vertical velocity, and the third position goes downwards. Thus, we can say at maximum point the vertical velocity equals to 0, and at final point the vertical velocity will be equals to the negative of the initial vertical velocity. Now, what about the initial velocity? Well, brothers and sisters, that is when we use the resolving factor. Yeah, let's go. In resolving factors, there are 4 components that you should be familiar with. The first one is the velocity, second one is the theta, the third one is the velocity in x direction, and lastly, the velocity in the y direction. So, how do we find the velocities in x and y directions? Basically, we can just use the trigonometry way. Sah, cah, to, wa. First, let's find the velocity in x direction. As we can see in the triangle, velocity in x direction is the adjacent and the velocity is the hypotenuse. So, A and H means we can use CAH, C-A-H, which means we can use cos theta. So, velocity in the x direction equals to phi cos theta. Second, let's find the velocity in y direction. Again, velocity is the hypotenuse and the velocity in y direction is the opposite of the angle. Means O and H. So we can use velocity in y directions equals to velocity times sin theta. Next, our third point is the accelerated motion formulas. And there are 3 main formulas, Sutat, Fuas, and Fuat. So the first one is Sutat. It is displacement equals to initial velocity times time, then added by half of acceleration times time square. The second one is Fuas. It is the square of final velocity equals to the square of initial velocity and added by twice of acceleration times displacement. Lastly, Fuat. It is very simple. It is simply final velocity equals to the initial velocity added with the product of acceleration and time. Now, acceleration formula is actually the derivation of this formula, Vuat formula. Nah, those 3 formulas are only for the y components. So how about the x components? Well, brothers and sisters, we just need to use the one and only s equals to v times time formula. Now, let's elicit the formulas, shall we? The first one is Sutat. The second one is Fuas. The third one is Fuat. And lastly, for the x component, we use the famous s equals to v times t. Now, last but not least, kinetic energy and potential energy in projectile motion. Let's start with GPE. When the ball is close to the ground, the GPE decreases, but at maximum height, the GPE reached its highest value. Next, the kinetic energy. When the ball has just projected in the air, the kinetic energy increases. And when it reached maximum height, the kinetic energy is 0. And when the ball comes back again to the ground, the kinetic energy increases. Now, as you know, the formula of kinetic energy is half of the product of mass and the square of velocity. One thing to be noted is that the velocity here is not the Vx nor the Vy, but it is the velocity with the diagonal line. Lastly, GPE formula. It is the famous mass times gravity times height. And one thing to be remembered is that the unit of gravity is ms minus 2 and not kilogram ms min 2. Our last thing in this video is doing the past papers. Here we go. For the past paper, I am using Winter Series 2014 and question number 2. Now, first of all, let's draw the x and y table components first. And list down the generally known variables such as ax equals to 0, ay equals to negative 9.81, and the initial velocity of y component is 0. Next, list down the variables given from the question. It is said that v at 60 degree to the horizontal. It is also stated that there is the vertical component, which indicates that it is the velocity in the y direction. And from the graph, we can see that the velocity is 5.9 meter per second. Now, as for the time, it is given that it is 0.6 second. However, let us take a look at the graph. It is stated that it is at velocity equals to 0, meaning it is only until the ball reaches the maximum height. So only half of the time for the full projectile motion. So we can list the time at height maximum is 0.6. Next, the first question states that we have to complete the graph. Now we can see that the graph only shown until the ball reached the maximum height, as the line ended at the x-axis. So we have to draw the graph when the ball is going down. So let's find the final coordinates. First of all, the y coordinate, which is the velocity in y direction. And as this is when the ball has almost reached the ground, meaning that the final velocity equals to the negative of the initial velocity in the y direction, which means it is negative 5.9. Next, we need to find the x-coordinate, which is the time. Here we are given that half of the projectile motion is 0.6. That means for the whole motion, it is 0.6 times 2 equals to 1.2. So we have the coordinates here, which is 1.2, comma, negative 5.9. So we can just look for the point there. Yep, over there. And then we can draw a straight line, continuing from the line provided. And lastly, you need to use the ruler, or you won't get the point. Now, for the second question, it is we need to find the maximum height, meaning we need to find the the displacement in y direction, because we are asked to find the height. Now, there are two ways to find the sy. The first one is the formula, and as we have provided a graph, we can use area under the graph. So first of all, I will review how to do it using formula. To use the formula, we need to find the variables that we know. We know the u, we know the a, and we know the t. And here, as we need the height maximums, we use the time when it reaches the maximum height. So here, the variables that will be used are s, u, t, and a. So we can use the SUTAT formula. Now let's just substitute the values here and put them into the calculator. Now the result is 1.77, and we need to make it to 1.8 because we need two significant figures. The second method is using the area under the graph. As it is stated only until it reaches maximum height, the second only until 0.6. So it will form this triangle, and we can use the area of triangle equation, which is half of the product of base and height. Now the next question is talking about the VH component, which is the velocity in x direction. Now if you can, if the question is asking about Vx or Vy or blah blah blah, you can straight away think about the resolving factor. Now the variables given are the Vy, and then the theta and the Vx. So yeah, we can just simply use trigonometry. And we can just draw the triangular like that to make it even much simpler to be understand. So the known variables are the Vy equals to 5.9 meter per second, and the theta is 60 degrees, right? And it is stated on the diagram. So here, we know that Vy is the opposite of the angle, and then the Vx is the adjacent, so we can use TOA, which is tan theta equals to O per A. We can just straight away substitute the variables into the equation, meaning tan theta, tan 60 equals to, the opposite is 5.9, and divided by the Vx, and we can just divide 5.9 with the tan 60, which is indeed equals to 3.4, and we need to round it up to two significant figures. So we have the Vx here. Lastly, we need to sketch the VH graph into the graph provided. And we know that the Vx is constant and t is for the full projectile motion, which is, we have known it is 0.6 times 2, which is 1.2. So the final coordinates will be 3.4 in the y-axis, and in the x-axis is 1.2, and we can just straight like that because it is constant, so it won't change. Also, don't forget to label the graph with VH label, or you will get your points eliminated. Next, here comes the kinetic energy and potential questions. So it is stated that the mass of the ball is 0.65, and BI is asking about the kinetic energy. As you know, kinetic energy's formula is half of the product of mass and the square of velocity. Now we have got the mass, but how about the velocity? Because here the velocity is not the horizontal velocity nor the vertical velocity. So we have to find the velocity that which is the diagonal line. Exactly. So how do we find it? Well, it is quite simple as we already know the theta and the Vy. So we can just use the trigonometry again, which is Vy opposite and the V is H, so we can use saw, which is sin the theta equals to opposite divided by hypotenuse. Yep, now we just have to substitute the variables. Sin 60 equals to 5.9 divided by V, and V is equals to 6.8 meter per second. And don't forget, it must be into significant figures. Now, we need to find the kinetic energy. Don't forget, that's only the velocity. So we just substitute all of the values. Thus, we can get 15.1 joules. And remember, to significant figures, it must be 15. Yep, joules. Now, on to the very last questions finally. Now, the last question is asking about the maximum potential energy. And of course, you can use the GPE here, which is equals to mass times gravity times height. The mass is already stated 0.65 kilograms, and the gravity, of course, it's constant, 9.81. And about the height, it must be a maximum point because it is asked the maximum potential energy. So we can just substitute the SY value, which is 1.8 meters. So we just have to substitute all of the values and put it in the calculator. Thus we can have 11.4777, or we can just simplify it, round it down to 11 joules. And that is it for the past papers. Now, that was all about the projectile motion. But before I close the video, let's elicit. Okay, so the first question is, can you tell me about x and y velocity on this diagram below? You can state whether the velocity is 0 or negative or etc. Next to the second question, let's do this. So it is, can you tell me about the accelerated motion formulas? All three of them. Now you can just write it down on a piece of paper. And lastly, to the last question, which is in the third question. And I will ask, how do you find Vx when known variables are the Vy and also the theta? Now that was all about projectile motion. Now, please do forgive me if I have said something wrong, but thank you for watching. And see you there again in Vanya's Physics. Goodbye. Wassalamualaikum warahmatullahi wabarakatuh. Bye-bye.